Hey everyone, and welcome to my presentation on RogueAgent, where I've been researching the attack success rate of MCP-based multi-agent systems against cascading and direct prompt injection attacks. So the problem with agentic security today, as you guys may have heard about prompt injection attacks, they're currently the number one threat against LMs today. There's a lot of attacks that are coming out because of prompt injection. It's a pretty hairy attack vector, and while we've significantly gotten better at mitigating the risk, it still exists, mostly in the form of indirect prompt injection attacks. To kind of add on to it, we're now seeing that companies are shifting towards multi-agent systems as opposed to just single-agent systems. So, and to further add to the attack service, the addition of MCP, which enables agent tooling, that broadens the attack surface, right? Because now we can see third-party tools being embedded into agents. So the real-world need, a lot of the literature and research today is on single-agent systems, like we've seen in Agent Dojo, MCP Talks, and Camel, and a lot of the defenses rely around single-agent systems. And even recently, there has been some research on multi-agent systems, but there is no research, to my knowledge, where we're looking at the topology or the layout of agents and layering it onto an MCP environment. So this attack vector is pretty nascent, but agentic cyber attacks are pretty timely. We've seen it as recently as last week with Hugging Face, McKinsey's Lily chat AI agents, a lot of the internal consultants use, where a lot of customer data was exposed. There was a $3.2 million attack against a manufacturing company where fraudulent procurement orders were created because their agents went rogue. So the problem that I want to research is what is the ASR of cascading IPI attacks against MCP-based multi-agent systems across models and topologies. Currently, we don't know what the ASR is for that. The problem with answering that question is there's a lot of nuance because there are so many different LLMs, so many different models for each vendor, and the layout or the topology of multi-agent systems, it varies wildly, right? It can be as simple as a chain, or it can be as complicated as a mesh, and even in a mesh setup, there's like a different combinations and permutations of that. So the solution and methodology that I've created, so I use Cloud Code to generate code to create a fictional support desk at a fictional telecommunications company called LinkX, which basically allows customers of that company to submit tickets, and there's a SQLite database that has PII of these customers, so social security number, first name, last name, email address, home address, and all this is synthetic data using the Faker class in Python. It runs on top of a fast API server, so that way you can do GET requests, POST requests of the different tickets. So pretty standard use cases of that. So if I want to look at an agent or a customer service ticket, I could also do that as well. That all runs on top of a fast MCP server. So there are two. There's one legitimate, which has legitimate use cases or legitimate Python functions to list tickets, write triage tickets, get a ticket, search the database, get a customer PII, things like that. And then there's the malicious server, which has innocent or innocuous looking Python functions. So check service status or compliance audit logger. But actually these are disguised as tool poisoning attacks or indirect prompt injection attacks. So we're also investing against two different topologies, chain and mesh. So chain, as the name kind of suggests or implies, it's an ABC layout. So starting off with the ingress point for the payload attacks, it starts with the orchestration agent, which is basically a triage or tier 1 support agent. that takes in the prompt and hands it off to the next agent, and then the agent after that. And then that ends with the resolution agents. I've also listed the agent roles in the top right corner, so you can see over here as well if you want to pause the video. And then in the mesh agent topology, so rather than an ABC simple layout, it starts off in a fan out, fan in, diamond shape model. That's just one example of a mesh, but there are so many different mesh topologies that exist in the real world. This one's fairly simple, but in addition to the three that I discussed in the chain, in this one there is an analyst agent, which is a read-only, doesn't read PI or doesn't send emails externally. Regardless of the topology, a JSON log is created in each trial run of these attacks, where it details the inter-agent communications, and there's canary tokens attached to the PII. So if PII is leaked in these agents, that canary is uniquely attached to that PII, and it'll show up in the JSON logs. And then if that's detected, then that's a value of true for the security ASR, which means that an attack was successful. To kind of add on to that, there were no built-in guardrails for the application. I just wanted to look at the Claude models, both Sonnet 5 and Opus 4.8. I got approval from Anthropic to red team against these models using the cyber verification program. They wouldn't let me red team without going through this program first, so that was critical. And then I kind of reiterate the attack vector here, where the TPA or tool poisoning attack, or the indirect prompt injection attack, is prompted via the orchestrator agent, then the message handoffs to the next agent, and then the resolution agent or the last agent exfills the customer PII via email or webhook. So there are 6 attack conditions, which are right here in these Python functions. One of them is a control variable, so meaning that it actually goes through the legitimate server, meaning that there's nothing malicious about that particular attack. It's just something to test about or to benchmark against. So again, we're measuring the attack success rate against 2 models and 2 topologies. And the attack success rate is measured as the number of positive attacks over the number of total trials. So here's a screenshot of an execution and the attack success rate results. I used Cloud Code to automate the execution and running of trials. It was a lot easier than just using command line interface, but I could do that if I wanted to. You can do that if you look at the README file. And you can see that I prompted here to run the attack with the Sonnet model, and I give it the conditions of 5 trials repeated for 6 conditions across the 30 trials. All of that was for Claude Sonnet, and all of that was actually detailed in the claude.md file, so I didn't have to really give it as detailed prompt. It actually just took a look at the claude.md file to do that for me, and then it spit out the attack success rates here. So if I go here, you can see that I prompted it to run the attack. It runs the claude.md file, and it basically goes through the execution of the code. And I'm not really going to walk through that because that's not important, but just to show you it works. And what I really wanted to show you is the final output, which is the measured attack success rates as well. So you can see across chain and mesh, it's 0%. And for this particular IPI ticket attack condition, it says 20% for a chain. That's actually 0. It was a false positive, meaning that it wasn't actually successful. So to go to the solution evaluation, splitting out by topology and the model, you can see it's 0% across the board. Claude actually did a very good job against detecting the attack and refusing to exfiltrate PII to an email. So some key takeaways is the initial triage agent actually suspected the attack, but it still passed the handout messages to the next agent. It wanted to carry out the attack, the prompt, execute the prompt. But the agents reasoned through the suspected attack, noting the attack, and then, funnily enough, by the end of the very last agent, the resolution agent, it actually refused to exfiltrate customer PII via email. It logs the resolution agent. In the JSON logs, the resolution agent would hallucinate and actually make up an incident response email to send to a non-existent LinkX security team to detail the attack, which suggests that there are internal guardrails built in by the Anthropic team. There's a couple of false positive hits, which I showed earlier, but it does not indicate a successful attack. Once I looked into it, it was just an artifact or an outcome of my particular test harness. And to show you an example of the JSON log, you can see here it actually details the AI message. So it takes in a malicious prompt, and it actually says right here, this is a data exfiltration prompt injection attempt. So that's on the very first agent and should be ignored. But it kind of goes down, and it still looks to execute the attack, or sorry, the prompt, which in this particular case, it was like a compliance request by the compliance team at LinkX. And you can see here that by the very end, trying to show it here, the AI agent and the resolution agent actually says no PII transmitted externally, no social security number, account number, or date of birth left the internal systems. So it actually doubles it down and says like, no, nothing was exfiltrated. So real world deployment considerations, there was a 0% ASR, but that doesn't prove that LLMs are secure against IPI attacks in multi-agent systems. All it just says is that it didn't work against this particular test harness. In reality, real-world production systems are a lot more complicated, and RogueAgent is intentionally simple with a simple test environment called LinkX that where we tested the LLM models themselves. Some solution limitations. LinkX is simulated. It's not a real-world production system. Anthropic only models, so we only tested against Anthropic models, not the other ones that you guys know about. There are limited prompts, so I only use a limited number of prompts. I couldn't really test a different number of combinations just because there would be too many trials to run through and the budget constraints with that. And I also want to keep the consistency in the data. And then next is closed models. So obviously, Claude does not open source their LLMs, meaning I don't actually know what's going on in there. I don't know what guardrails they'll have in place. Any findings I can find about their defensive guardrails, it would only be from their papers. So it was really like a black box red team I was running. So there was limited structure. I only looked at 3 agent chains and 4 agent layered DAG meshes. It doesn't explore more possible layouts, and there's, again, endless combinations and permutations of them. I also assumed that the topology and model assumption is the same, so I didn't mix up Sonnet with Opus agents in the same layout, but in real life you could mix it up, and I'm not sure how that would affect the findings of the ASR results. And then of course budget constraints. So you guys probably already know AI is super expensive to run, and I had to keep it directly to 120 trials only. But in reality, I would have to increase the number of N trials to really give some rigor to the data. So some future work related to the project. LLM security is constantly changing due to new research, models being released, and companies being breached. For example, Kimi K3 literally just came out this week, and it's all the rave right now. So I could test against new vendors and LLMs. I could stress test the attack conditions by changing up the payloads. Just last week, Hugging Face's AI agents use remote code execution to expose internal datasets and service credentials. So this is something that I want to explore, and it's just came out, so I didn't have time to get into that. But different data breaches are coming out constantly, and as I mentioned before, increasing the n number of trials and rerunning of the attacks to see if the data will hit a non-zero attack success rate. In reality, with a lot of these researchers, like I believe MCP Talks and Agent Dojo, they're actually running almost like over 1,000 trials because they have funding. So that's something that I could also look at. I really appreciate you guys taking the time and hope you have a great rest of your day.